And I truly hope that this demonstration kind of suggests that how powerful and how simple it is to use standard library. Most of the time with all standard operations you will find a lot of support in the standard library. Let's take a look at some other examples for demonstrating work with containers. Let's see. Stack operations. They're really just a couple of stack-like operations. You already know how the stack looks and feels like. Push and pop. So in case of a vector, this time we create a vector of characters, right? So vector of characters, first you can push elements to the vector of characters, and says push back, character A gets pushed, push back B, so another character is pushed, right? So then I can have a little loop that does it in a loop and basically populates it with more characters in a range from D to G, and now we have ABC, D, E, F, right? So we have this little loop. Now if you want to remove elements, again, if you want to remove element in a stack-like manner from the vector, right? By the way, in our homework assignments related to stack of integers, we could have used vector, and this would be very successful implementation of our stack container, right? So we say pop, it just gets removed at the bottom. So here, another example, while vector 1 size is not 0, just pop everything here, and you run it, and just everything is removed. So the elements were removed one by one. There's also an erase member function which will remove all elements instantly. List operations. Okay, so actually let me try to view some of this iterator. Let's try those list operations. All right. So this time the sample suggests that, okay, take a look at this. A vector of strings. In fact, this is going to be named fruit, and it's going to have 2 apples in it, right? So create a vector of strings populated with apples. Then push back. We've seen this push back, so it's going to add some other, watermelons and lemons and this and this and this and this. Just push back a whole bunch of things. Then create a copy of it, fruit 2. So we're going to look at some of the list operations as opposed to stack operations and what they are. So we're creating fruit 2. Very simple. Just vector of strings fruit 2 equals fruit. So it's just do this for me, make a copy of this, and it happens, right? So this one is called fruit, this one is fruit 2. And by the way, absolutely true thing is that remember that this code is executed in the background by this program, and there is a way to visualize it, because as it runs, it actually makes a recording. That's why I can jump back and forth in this thing, and the recording of the initial execution is played back, and we can visualize it and see what happened then when the code was executed. So all right, so actually making those examples wasn't too hard once the containers were defined and they could do what they do right now, visualizing themselves. All right, so here's an example of an algorithm, our first view of an algorithm. By default, strings can be sorted when they're compared. They're case sensitive. So in this case, I'm expecting this sort call to an algorithm to sort everything in such way, and we're about to sort fruit 2, that obviously grapefruit, which has an uppercase in its name, should be pushed right at to the top of the container. Everything else should be sorted alphabetically according to the lexicographical order of characters defined by our character set. So sort, right? So an algorithm here is displayed as basically as this block thing, but it's just a function call. So this function call took beginning and ending of this vector, and now since internally iterators are used, those lines that you see here in this kind of rigid animation, they're actually objects that are being created internally, and they're iterators. And as you can see, those iterators basically are used inside the sort function to connect themselves to particular locations. And what it's doing, it's just doing this, executing the sort algorithm. So it needs to go through the entire container and swap elements, back and forth to implement some quick sort algorithm, whatever sort algorithm it does. And as the execution takes place, everything becomes animated, and this animation really does take some time to play back before everything eventually is getting sorted. So you can play with this a little bit, but in the end, when we're done, iterators, which are temporary objects created during this sort algorithm, they're all gone, right? So they're just helper objects which were helping this function to go to different places in this container and essentially access different. So this is an example of an algorithm, right? But we haven't gotten yet to list operations. We just said, okay, let us sort this container. Now notice how simple this was. One line of code. This comes from Standard Library. The sort comes from Standard Library. Vector, of course, also comes from Standard Library. And one line of code, and you got this sorted, right? So, an example of iterator right here also is the syntax, and perhaps I can try this in our code to demonstrate this. Where's my project? All right, so I have a vector of strings that contains string hello someplace, right? So let me just put it like I don't know, 56th element of this vector of strings will contain hello. That's fine. So now I want to find it similar to this example here. I want to find something that says hello inside of my container. There is an algorithm. It's good to, by the way, sometimes if I don't remember if such algorithm exists or not, some of the algorithms are here, but there's more in the book that you need to be aware that they exist. We'll actually look at some of these algorithms very soon. But right now, just take my word that find is one of the algorithms that basically searches for a value inside Standard Library container. So now I have to specify that I want, now how does find connect with my vector? Well, through iterators. I need to say find, take, go from the beginning and member function called begin into this vector that I have is going to return an iterator object back, right? So it's designed to give back an iterator, which find will happily take as a parameter to say, where do I start? And I say start from the beginning. Or I could say start from like beginning plus 1, whatever, but I'm not going to do this. Then where should I end? Okay, not a problem. So you should end right at the end, but if you find it earlier, stop the search and give me back my value. So this will be an ending here, and then find tells me what would you like to search for. Okay, search for hello, right? So hopefully it can be found. To be able to use algorithms, this demonstration doesn't really give you a full program, but to be able to do this, really, you need to say right here, algorithm. This guy brings in all the algorithms from the Standard Library. Okay, so but the question is, what does find return back? And the answer is, it also returns back an iterator, which will behave as a pointer to the string hello is if it was indeed found in this position. So let's examine this part.